Alright, guys, so today I'm going to be walking through the 2020 A1 maths paper for statistics, and then I'm going to do mechanics as well. So, we'll go look at the first question. We've got a Venn diagram shows probabilities associated with the first four events, A, B, C, and D. So we've got a Venn diagram there. We want to write down any pair of mutually exclusive events from A, B, C, and D. So mutually exclusive means they've got to be separate from each other. So in this case, the only mutually exclusive event for part A would just be A and C. They're the ones that are mutually exclusive from each other. So A and C for the first bit. Part B, given that the probability of B is 0.4, we're going to need to find the value of P. Okay, so we're given that. So that means that we can add up all the probabilities in B, and then that should hopefully be equal to 1, and then I can solve for P. Alright, so what I'm going to do is I'm going to do 0.24 plus 0.07 plus P has got to be equal to the probability, which was 0.4. So I can get P out really, really quickly, which is 0.09. It says, given also that A and B are independent, find the value of Q. So A and B are independent. So independency is saying the probability of A and B is the probability of A times probability of B. Now I know what the probability of A and B can be because I can just add them all up, right? So it's literally just going to be 0.24. I can do that relatively quickly because it's just the intersection of both of them into i.e. is this bit here. So we know that. We know the probability of B is 0.4. Now the value of Q is the probability of D. So we can say 0.24 is got to be the probability of A times 0.4, because if we find the probability of A, we can very easily find what the probability of D is going to be. So the probability of A would be 0.6, I believe. If I had that up right, yeah. Cool. So all we need to do now is just sort out what the probability of Q is. So it'll be 0.24 plus 0.16 plus Q is got to be equal to 0.6, isn't it? What we just added up there. Alright. So that'll give us Q. I'll just take everything to the other side. Q will get me 0.20 there. Alright. So a nice, fairly straightforward probability question to start us off. Now this page, I think, will move with us. Yep, there we go. So, given further that the probability of B not given C is 0.64, find the value of R and the value of S. Okay. Now, I kind of expected this was going to come into play here. So we're given that probability. Now, there's a formula that applies to this here, down at the bottom. Now, that is the probability of C and not B divided by the bit you're conditioning on, which is the probability of C, which is just R over P plus R, which we can put equal to 0.64, and we know P is 0.09, so we can get R over 0.09 plus R. Now, if you solve that, is it 0.16? I think it is 0.16. Cool. Easy mark there. So the value of S for the second part of the question, well, that's just everything but the outside, isn't it? So it's just 0.4 plus 0.16 of 0.36 at S is equal to 1. So that'll be 6. 0. Is it 0.08? I think that adds up right. Cool. Right, so that is how we can do question 1 on this statistics paper. So, fairly straightforward. Just make sure you remember the conditional probability formula in the formula booklet, I think. Yeah. Question 2. We've got a random sample of 15 days taken from a large dataset for Perth in June and July 1987. The scatter diagram in figure 1 displays the values of 2 of the variables for these 15 days. Describe the correlation. Now, you could be very, very short or very, very long-winded in terms of the question. I think all you need really is just to say it's negative. I think if you give any more, I won't even bother because you don't need to. A straight 1 mark, just say what you see. It's going down, it's negative, move on. Simple as. Right. The variable on the x-axis is daily mean temperature measured in degrees centigrade. Using your knowledge of the large dataset, suggest which variable is on the y-axis. Okay, well let's think about this. If we've got daily mean temperature, then we could have something maybe about something about rainfall, perhaps. Rainfall's not a bad shout. Now, rainfall, the units that rainfall is measured in is millimeters. So make sure we state that out. Now, this is a hypothesis test. Carry out a subtle test to investigate Stav's belief at a 5% significance. 5% level of significance states clearly your hypotheses and your critical value, given that R is minus 0.377. Right, so how do we set these up? Well, it's fairly straightforward. I'm going to move on to the next bit of paper here. So, we write it out. This is going to be very long-winded. We're going to let rho be the probability, be the population correlation coefficient. Our null hypothesis is every single time that rho will be 0. So we're stating that there's no correlation whatsoever. The alternative, well, we don't know which direction it's going to be, so I'm going to put it as not 0. It's a two-tail hypothesis test. Now, I usually write down what I'm testing. So I've got an N of 30 trials, and I've got a sig level of 5%. Now, that is good for a one-tail test. However, we've got to divide this by 2 because it is two-tailed. Now, half of 5% would be 0.025% sig level. That's the important bit. If you don't remember to halve your significance level, or i.e. divide it by 2, you're not going to be able to access this question because you basically won't remember how to do the problem. Now, I usually draw a diagram for something like this. So, quick diagram just to illustrate what's going on here. So we have minus and then a plus, don't we? Now, I believe if I scroll back up to the top, we're given minus 0.377. Now, if you look up in the formula book, the value, I believe, I've got the formula book next to me, you can tell me if I'm wrong or not. I think you get 0.3610 if you look in the formula book under the 0.025% significance level with N is 30. I think you get that. Now that's important because if 0 is there, we've got to take the positive of that because we don't know if it's going to be positive or negative. We're going to be looking at what end of the scale. Well, you're going to be looking at this end of the scale and this end of the scale, aren't you? Between minus 1 and 1. Now the critical value will be what this minus 0. That's your CV. Now, it does say that R, which is the minus 0.377, is less than the minus 0.3610, less than the critical value. So the result is significant. There is evidence to suggest there is correlation between daily total sunshine and daily mean relative humidity. Now, because it is a hypothesis test, that's what you have to write out every single time. I know it's a little bit of a mess, but yeah, you have to just get used to writing it down all the time. Right, I believe there's one more bit. There is. Comment on the number of hours of sunshine you would expect on that day, given a reason for your answer. Given that on a random day at Heathrow, the daily maximum relative humidity was 97%. So this, straight away, that's incredibly high, 97%. Now we also know that R must be less than 0. So it'd be lower than the expected amount of sunshine. Okay? Given that it's incredibly high humidity, the hours of sunshine you would expect would be less. Okay? Right, next question. Ooh, question 3. I like this title. There's not actually that many questions for statistics, is there? So we want to find the range. Well, the range is pretty straightforward because we just need to make sure we can add up correctly. So I've got 68 over here. Let's make sure the pen's on. Yep, 68. The lowest value is 7. 68 minus 7 is 61. Nice and easy. Find the interquartile range. Well, the interquartile range is Q3 take away Q1, i.e. it's be 25 minus 14, which is 11. I can do that reasonably quickly because I'm looking at this end here and I'm looking at this end here. And I'm just looking at the difference between them. Done. This line in the middle of the box at the 20 would be the median. That's it. Now, you might just see it called a box plot instead of a box and whisker plot, but it's the same thing. That's what can throw people off a couple of times. Now, we also told 27 people, so that's kind of important for this next bit here. For these 27 people, the sum of x is 607.5, and the sum of the x squareds is 17623.25. Calculate the mean time taken to complete the puzzle. So the mean in sigma notation would be x bar the sum of x over n. So the sum of x is 607.5 divided by 27, which gives you 22.5 on your calculator. Cool. Part D, calculate the standard deviation of the times taken to complete the puzzle. Now, standard deviation is going to be sigma, which is the square root of the sum of the x squared over the n's minus the square of the means. Now, if you sub every single bit of that into your calculator, now it doesn't tell you to what degree of accuracy. Now, I've got 12.1 on a load of random terms, so I think 12.1 to 1 dp, I think, is most accurate. It's just a case of substitution where you've got the sum of the x squared, the sum of the x's, which you've already got as 22.5 anyway, so it's fairly straightforward and fairly quick. Toruni defines an outlier as a value more than 3 standard deviations above the mean. State how many outliers Toruni would say there are in these data, giving a reason for your answer. Now, 3 standard deviations above the mean would say that x bar plus 3 standard deviations is roughly 58.8, using that rounded value for the standard deviation that I got. So 58.8. Now, if we look back at the diagram, so if you look back at the diagram, right at the top of the page, you'd expect, given it's 58.8, there's only one outlier, which is about 40 something or other, is it? 46. So there's only one in between that. So we can state there'll be only one outlier, saying using what they give. Now, Adam and Beth also completed the puzzle in A minutes and B minutes, respectively, where A is bigger than B. When their times are included with the data of the other 27 people, the median time increases, but the mean time does not change. Suggest a possible value for A and a possible value for B, explaining how your values satisfy the above conditions. Okay. So the median increases. Well, that definitely means that if you take A and B and multiply them together, then it's clearly going to be bigger than 20, because that was the median. So we also can state by a fact that if we take some value A plus B, which is another value we could say is Y, and we say that Y divided by the 29 for the mean, it's got to be 22.5. The value for the new mean is 652.5. Okay, useful. Now, if I take that away from the original mean, so 652.5 minus the original one, 607.5, that gives you 45, doesn't it? So we know then that A plus B has to be equal to 45, because we are saying that Y is the addition of these two values. And we also know that A is greater than 20 and B is greater than 20, so A must be bigger than B. The only way that will satisfy it is if A is 24 and B is 21, as A has got to be bigger than B, and A has got to be bigger than 20, and B has to be bigger than 20. Fully justifying with their answers. You've got to do it. Part G, without carrying out any further calculations, explain why the standard deviation of all 29 times will be lower than your answer to part D. Okay. So we got this mean and the standard deviation, didn't we? The values less spread out. So small standard deviation as less than 1 SD from the mean. Yeah, I'm happy with that. It kind of makes sense to us as well, doesn't it? Anyway, moving on. Alright then. Question number 4. The discrete random variable D has the following probability distribution. Okay, so we've got a table. Cool. show that the value of k is 600 over 137. Lovely. So, in this case, we know that the sum of all probabilities in the probability distribution will be equal to 1. That's one of those key facts that you learnt in the first year statistics book. So all I'm going to do is add them all up, equal to 1, and then show that. Fairly straightforward. So if I add these all up, just so I'm lazy, I'm just going to put pluses next to them all. So if you do add them all up, you get 137 over 600k is equal to 1. Now, that's pretty straightforward to give you that k is 600 over 137, because you can just times by that fraction flips, i.e. giving what k is. Fairly straightforward, I hope. Part B says the random variables d1 and d2 are independent, and each have the same distribution as d. Find the probability of d1 plus d2 equals 80, giving your answer to 3 significant figures. Okay. Well, it could either be 40 plus 40 or 30 plus 50, wouldn't it? I.e. it's going to be either k over 40 times by k over 40 plus k over 50 times k over 30, or the other way around, k over 30 times k over 50. So we get k squared over 1600, k squared over 1500, and a k squared over 1500 again. Okay. Now, if we add them all up together, we get that if you do it on your calculator. I've just done it myself. Now, we know the value of k. So if you sub k in for that, let's try it. Let's do it on my calculator. You get the probability of d1 plus d2 equals 8 is 0.0375619, so 0.0376 to the 3 significant figures. So all I've done is thought about the combinations of adding two numbers together and getting 80. That's all I've done. And then used that distribution from the table, added them all up, and then substituting that value of k that you got from part A into that formula. 47k squared over 24,000, which gives you what you wanted. Alright, cool. Moving on. Right, so a single observation of d is made. The value obtained d is a common difference of an arithmetic sequence. Ooh, nice. The first four terms of this arithmetic sequence are the angles measured in degrees of quadrilateral Q. Find the exact probability that the smallest angle of Q is more than 50 degrees. Right. So, it goes A plus D, A plus 2D, A plus 3D, all the way up to 360. Because we're told that they are a quadrilateral and the sum of the angles of a quadrilateral is 360 degrees. Now, if you add them up, you get 4A plus 3D will be equal to 360. And we get 2A plus 3D is 180. Now we choose values of D in order for this to work, don't we? D is 10. Get A is 75. Okay, I'm happy that works. If D is 20, or if D was 20, you'd get A is 60, wouldn't you? Then if you look at being D is 30, you're going to get that A is 45. Now, that doesn't add up right, because that is less than 50. So, it fails, we stop. So, it's literally just going to be K over 10 plus K over 20, isn't it? Because it's when D is 10 or D is 20, which is those two values from the table, which is 3 lots of 600 over 137, and divide that by 20. Right, let's try it on the calculator, see what we get. We've got 3 lots of 600 over 137. We're dividing that by 20. Which is 90 over 137. Alright, that's the exact probability, so I'm not going to convert it to a decimal. Alright. How many more stats questions do we have left? I might break this video into 2, actually. Is this the last question? Yeah, question 5. Alright. We'll have a look at this one, and then I'll split it up into the second video for the mechanics. A health centre claims that the time a doctor spends with a patient can be modelled by a normal distribution with a mean of 10 minutes and a standard deviation of 4 minutes. Using the model, find the probability that the time spent with a randomly selected patient is more than 15 minutes. So, fairly straightforward. We can set up a normal distribution. X follows a normal distribution. It's 10, 4 squared. Okay. Now we want the probability that X is bigger than 15. Now to do that, I can jump straight on the calculator for that one, and I get 0.106. Cool. Part B, setting your hypothesis clearly and using a 5% level significance. Test whether or not there is evidence to support the patient's complaint. Now, sample of 20, 11.5 minutes for the mean. Useful, because then I can get the sample mean, X bar, is normally distributed of 10, 4 squared over 20. You've got to be careful there. It's the standard deviation squared over n. The null hypothesis will state that mu has got to be equal to 10. The alternative will say that mu has got to be bigger than 10. We want the probability that X bar is bigger than 11.5. Now, on your calculator, it's menu into number 7, and we're looking for normal CD. We're picking on that value of 11.5. We'll pick an extremely big value. Our sigma is root 4 squared divided by 20. And our mu is 10. Which is, blimey, it's 0.0466766. That'll do, for a reasonable degree of accuracy. Now, this is less than 0.05 than this significance level that we're testing. So, there is evidence to suggest that the complaint is indeed correct. Okay, giving it in context of the question every single time. Okay, part C, part I. Find the probability that a routine appointment with the dentist takes less than 2 minutes. Okay, not a problem. We want the probability of t being less than 2. That's fine, I get 0.1956. Or 196 to 3dp. Part 2. Find the probability that t is less than 2 given that t is bigger than 0. Now that is the probability of 0 less than t less than 2 divided by the probability that t is bigger than 0, which is 0.119119 divided by, 0.923436. If you divide them out, you get 0.129 to a reasonable degree of accuracy of 3dp. Hence explain why this normal distribution may not be a good model for t. Well, it's suggesting non-negligible values of t less than 0. Which is completely impossible. The dentist believes that she cannot complete a routine appointment in less than 2 minutes. She suggests that the health centre should use a refined model only including values of t bigger than 2. Find the median time for a routine appointment using this new model, giving your answer correct to 1 decimal place. So, we're given that t is normally distributed of 5,3.5 squared. Now, we want to do it using the fact that the probability of t being bigger than little t divided by it's got to be equal to a half, hasn't it? Because it's half of the distribution. So I've then got the probability that t is less than little t is 0.5978. Now, to get t, I need to go to number 7 for distribution, the inverse normal. Now my area is 0.5978. My value for sigma is the 3.5 I've written down, and I've got a mean of 5, which gives me the value of little t, 5.8667985882. So reasonable degree of accuracy to 1dp it wants, so 5.9 to 1dp. Cool. Right, so that's the end of the statistics half of the paper. I'm now going to end this video and put a new value up when we look for the mechanics section of this paper. Thanks very much for watching, and let's look at the mechanics paper.